This next scenario, we have Ryan, who takes a cart and puts it on an incline. And the information that we could have for this is our initial time and our final time and our time interval, delta t. We could have our initial position, our final position, and our change in position. And we can have our initial velocity, our final velocity, and our average velocity, or our change in velocity. And so Ryan puts the cart at the bottom. So our labels are not correct. We're now starting with time 0 being down here and y0 being down here. Things are reversed for us. And so this is V0. And that's V. So he puts it at the bottom of the 2.16 inclined plane. So if this y0 is 0, the whole inclined plane is 2.16 meters. So that means the final position is 2.16 meters. He pushes it upward with a velocity of 3.61 meters per second. So 3.61 meters per second. And what that cart is going to do is it's going to go up here and reach its top point, because as it goes up, it's going to slow down and it's going to stop. And it starts to come down. So we know it goes 3 to 2 to 1 to 0, and then it starts to come back down. So the velocity at the end is actually here somewhere, and the cart is now, it did reach a point up here, and it's now on its way down traveling in this direction. Well, if that's positive 3.61, if this is the positive direction, then this is the negative direction. So this velocity is minus 2.40 meters per second. It's moving in the opposite direction. That's what negative means, opposite direction. So we're looking for the average velocity. Now our average velocity, we have two formulas. V equals delta y over delta t, and V bar is V plus V0 over 2. Well, what information do we have? We have delta y, we have V0, and we have V. V0 and V, and we're looking for V bar. We do have delta y, but we do not know delta t. So the equation we will be using is this one, the average velocity 2 formula. So the final velocity is minus 2.40 plus 3.61 all over 2. And that then gives us a value of 1.21 over 2, which we divided out is 0.605. And since it's an average velocity, all velocities have units of meters per second. And the last thing we can do is we can express this in scientific notation. So V bar then would be 6.05 times 10 to the minus 1 meters per second. Now you may wonder, why is this 3? Well, why do we have 3 digits in our final answer, 6.05? Well, it's because this number had 3 digits and this number had 3 digits, and the 2 had an infinite number of significant digits. It's perfect, so 3 is the smaller number, and we're left with 6.05 times 10 to the minus 1 meters per second. This 0.605 is also correct, but the best answer is the one with the scientific notation at the end.